A researcher has a sample of 30 rats that are all cloned from the same source. The 30 rats are genetically identical and have been raised in exactly the same environment since birth. The researcher conducts an experiment, randomly assigning 10 of the clones to treatment A, 10 to treatment B, and the other 10 to treatment C. Explain why the clone experiment is better than a between subject study using 30 regular rats that are randomly assigned to the three treatments. In other words, explain how the clone experiment eliminates the basic problems within a between subject study. The way in which the clone experiment would eliminate the problem in a between subject study is that it would not provide a way for there to be any individual differences. As the problem states, the 30 rats are genetically identical and they have been raised in the exact same environment since birth. So basically, it's just the same rat who's been cloned multiple times. So when you have it done that way, then there's really no possible way to have individual differences because it's essentially the same rat. In a regular between subject study, you would have basically different people, different participants who have differences, and their differences would thus get compared. And once their differences are compared, then it becomes a threat to internal validity. But here with the cloning, you don't have to worry about that. Explain why the clone experiment is better than a within subject study using 10 regular rats that are tested in each of the three treatments. In other words, explain how the clone experiment eliminates the basic problems within a within subject study. So the problem would be eliminated here because by using the cloning, because there would be no carryover effects. So you have the 30 rats as shown here, and then each of the 30 rats are put into each treatment. So you have 10 rats put into this treatment, then you have another 10 put into this treatment, and then you have another 10 put into treatment C. And so by doing this, you don't have to worry about any rat having any kind of an effect in their new treatment. So for example, if rat number 1 were to do his treatment in treatment A and then he would go over to treatment B, there might be a possibility that there would be some type of effect or aftermath of him having his treatment in column A that would affect his treatment in column B. And then again he goes over to column C to do a treatment, and then there again the effects from treatment A and treatment B will affect his outcome in treatment C. So by having the 30 rats divided up evenly amongst the three treatments, then you don't have to worry about any type of effects making an impact on each separate treatment.